गुड मॉर्निंग स्टूडेंट्स। लास्ट लेक्चर में हम लोगों ने डिस्कस किया था गियर्स के बारे में। आज टॉपिक में आज स्टार्ट करेंगे हम लॉ ऑफ गियरिंग और फॉर्म्स ऑफ टीथ। ओके, सो कंडीशन फॉर कांस्टेंट वेलोसिटी रेशियो ऑफ टूथ व्हील्स, लॉ ऑफ गियरिंग क्या होता है? कंसीडर टू व्हील्स whose centers are O1 and O2. These two teeth are the teeth of these two wheels are in contact at the point Q, and the linear velocities at these points of wheel 1 and wheel 2 are V1 and V2. Okay, the common normal of these two wheels is Mn. Draw the perpendiculars from the centers of the wheels to the common normal Mn. Okay, if this angle is alpha and this angle is beta, okay, in that case this remaining angle will be 90 minus beta, and line O2Q, the velocity of the wheel 2 V2 is perpendicular to the O2Q because this is the linear velocity. Wheel 1 is rotating in clockwise direction and wheel 2 rotates in anti-clockwise direction. Okay, so if this is 90 minus beta, in that case this remaining angle will be beta. Similarly, from the triangle O1QM, if angle QO1M is alpha, in that case remaining angle in this right angle triangle O1QM will be 90 minus alpha. Okay, here linear velocity of wheel 1 V1 is perpendicular to the O1Q. In that case, if this is 90 minus alpha, then remaining angle will be alpha, and this will be the opposite angle, so this angle will be alpha. Okay, for constant velocity ratio, the velocity of component of velocity of wheels along the common normal should be equal to 0. अगर velocity का component common normal के along equal नहीं होगा तो एक व्हील दूसरे व्हील के साथ constantly mesh condition में नहीं हो सकता. So The component of the linear velocities of the wheels along the common normal should be equals to each other. Now the component of velocity of wheel 1 along the common normal is v1 cos alpha, and velocity of wheel 2 along the common normal will be v2 cos beta. Clear? We know that if the angular velocity of the wheel 1 is omega 1 and angular velocity of wheel 2 is omega 2, then in that case we know that linear velocity will be equal to the angular velocity multiplied by radius. So v1 will be equal to the angular velocity into radius, which is O1q cos alpha, equal to the omega 2 O2q cos beta. From the right angle triangle O1QM, cos alpha will be equal to the O1m upon O1q, and from the right angle triangle O2 and q, cos beta will be equal to the O2n upon O2q. From here, omega 1 by omega 2 will be equal to the O2n upon O1m. Okay, here triangles, if this is the point P, so now from here triangle O2 and P and triangle O1MP are similar triangles, so the ratio of the sides will be equal. So from here, from similar triangles, O1MP and O2NP, O2n upon O1m will be equal to the O2p upon O1p. So omega 1 upon omega 2 will be equal to the O2p upon O1p, where O2p is the pitch circle diameter of wheel 2 and O1p is the pitch circle diameter of wheel 1. Okay, so omega 1 upon omega 2 will be is equal to d2 upon d1, or we know that omega is equal to 2 pi n by 60, then n2 upon n1 will be equal to d2 upon d1. Okay, we know that module d by t, module is equal to d by t, and for constant meshing it is mandatory, compulsory that the module of the both the gears should be equal. So from here d2 upon t2 will be is equal to d1 upon t1, or say d2 upon d1 is equal to the t2 upon t1. So from the law of gearing, n2 upon n1 is equal to the d2 upon d1 is equal to the t2 upon t1. Okay. Now come to the next topic, forms of teeth. Okay. गियर्स में कितने तरह के टीथ कट्स होते हैं, कर्व कितने तरह से टीथ के कट होते हैं, वो डिस्कस करेंगे अब हम. फॉर्म्स ऑफ टीथ. In actual practice, there are two types of teeth commonly used. First is cycloidal tooth. Second is involute tooth. Involute tooth teeth. Okay. So what is cycloidal teeth? Cycloidal teeth. Cycloid is the curve traced by a point on the circumference of a circle which rolls without slipping on a fixed straight line. When a circle rolls without slipping on the outside of a fixed circle, the curve traced by a point on the circumference of a circle is known as epicycloid. On the other hand, if circle rolls without slipping on the inside of the fixed circle, then the curve traced by the point on the circumference of a circle is called hypocycloid. देखिए यहाँ पर किस तरीके से व्हील के टीथ को डिजाइन किया जाता है. यहाँ एक स्ट्रेट लाइन के अलोंग व्हील एक सर्कल को हम विदाउट स्लिपिंग रोल कराते हैं. तो यहाँ एक सर्कल है हमारे पास, इस पे एक पॉइंट हमने लिया P पॉइंट, और जब इसे हम रोल करेंगे विदाउट स्लिपिंग स्ट्रेट लाइन पर, तो इस तरह से कर्व बनेगा, फर्स्ट कर्व. दूसरी तरफ से जब हम इसको इसी सर्किल को इस पे एक पॉइंट को इस पर विदाउट स्लिपिंग अगर रोल करेंगे तो इसका अदर फेस बनेगा. इनको हम मिला सकते हैं. स्ट्रेट लाइन के नीचे अगर हम इसी प्रोसेस को फॉलो करेंगे, यहाँ पर हमने इसे रोल किया तो कुछ हमारे पास इस तरह से कर्व आएगा. सिमिलरली अदर साइड में भी हम इसी तरह प्रोसेस करेंगे तो ये कर्व बनेगा. तो टोटल सर्किल को सर्किल पे एक पॉइंट को व्हील हम उसको जब हम टर्न करते हैं, रोल करते हैं विदाउट स्लिपिंग, इस कंडीशन में उस सर्किल के सरकमफ्रेंस पर एक पॉइंट को अगर हम ट्रेस करें तो उससे हमें जो ट्रेस से जो कर्व फाउंड मिलता है, वो कर्व हमारा साइक्लॉइडल कर्व है. यहाँ पर ये हो गया बेसिकली पिच सर्किल. दिस इज अ addendum circle. This is dedendum circle or root circle. Clear? व्हील 1 और व्हील 2 के जो पिच सर्किल्स हैं एक दूसरे से टेंजेंट है at the point P. Okay, and XX is the common tangent of pitch circles. Okay, व्हील 1 का जो टीथ है हमारा कुछ इस तरह से है, और व्हील 2 का जो टीथ है हमारा ओके, in this diagram a point on the circle D will trace the flank of the tooth T1. Okay, when circle D rolls without slipping on the inside of the pitch circle of wheel 1, the face of tooth 2, when the circle D rolls without slipping off on the outside of the pitch curve of wheel 2. Similarly, a point on the circle C will trace with the face of the tooth T1 and flank of tooth T2. The rolling circle C and D may have unequal diameters, but if several wheels are to be interchangeable, they must have rolling circles of equal diameters. Okay. Now come to the involute teeth. What is involute teeth? An involute of a circle is a plane curve generated by a point on a tangent which rolls on the circle without slipping, or by a point on a taut string which is unwrapped from a reel. Okay. In connection with tooth wheels, the circle is known as base circle. C. इनवॉल्यूट प्रोफाइल डिजाइन किया जा सकता है जब हम एक लाइन को और लाइन पर एक पॉइंट को हम ट्रेस करते हैं और लाइन को विदाउट स्लिपिंग हम उसे जब रोल करते हैं सर्किल के अराउंड, और उस लाइन पर जो एक पॉइंट है किसी एक पॉइंट को ट्रेस करते हैं, तो ऐसे कर्व को इनवॉल्यूट कर्व कहते हैं। यहाँ पर लाइन को विदाउट स्लिप किए हुए रोल किया जा रहा है, तो ये जिस सर्किल पे से रोल कर रहे हैं उसे हम कहते हैं बेस सर्किल। और ये जो लाइन है वो रोलिंग टेंजेंट हो गई, लाइन ट्रेस कर रहे हैं पॉइंट को तो हमें इस तरह से कर्व बना रहा है। दिस इज द इनवॉल्यूट कर्व। यहाँ पर जो कॉमन टेंजेंट है, जो बेस सर्किल से टेंजेंट है यहाँ पर, ओके। तो जो इनवॉल्यूट प्रोफाइल्स हैं गियर्स के, उन्हें ट्रेस किया जा रहा है। यहाँ पर एक लाइन पर पॉइंट को ट्रेस करके कर्व को हम लोग बनाते हैं, इनवॉल्यूट कर्व को, ठीक है। यहाँ इस एंगल को हम कहते हैं प्रेशर एंगल फाई, ओके। Now the advantages of the involute gears. तो फर्स्ट एडवांटेज है इनवॉल्यूट गियर का, the most important advantage of the involute gear is that center distance for a pair of uh, involute gears can be varied within limits without changing the velocity ratio. This is not true for cycloidal gears, which requires exact center distance to be maintained. This is the first advantage of the involute gears. Second, in involute gears, the pressure angle from the start of the engagement of teeth to the end of the engagement remains constant. It is necessary for smooth running and less wear of the gears. But in cycloidal gears, the pressure angle is maximum at the beginning of the engagement, reduces to zero at pitch point, starts decreasing and again become maximum at the end of engagement. This results in less smooth running of gears. This is the second advantage of involute gears. The third advantage of the involute gears is the face and flank of the involute teeth are generated by the single curve, okay, whereas in cycloidal gears double curves are required for the face and flank respectively. Thus, the involute teeth are easy to manufacture, and cycloidal teeth in volute system, the basic rack has straight teeth and the same can be cut with simple tools. So this is the last advantage of the involute gears. Advantages of the cycloidal teeth or cycloidal gears. Since the cycloidal teeth have wider flanks, therefore cycloidal gears are stronger than involute gear for the same pitch. Due to this reason, cycloidal teeth are preferred especially for the cast teeth. So this is the first advantage of the cycloidal gears. The next advantage of the cycloidal teeth is in cycloidal gears the contact takes place between a convex flank and concave surface, where in involute gears the convex surfaces are in contact. This condition results in less wear in cycloidal gears as compared to involute gears. However, the difference in wear is negligible. So this is the next advantage of cycloidal gears. Now the last advantage of the cycloidal gears is in cycloidal gears the interface does not occur at the at all. Interference does not occur at all in cycloidal gears. Though there are advantages of cycloidal gear, but they are outweighed by the greater simplicity and flexibility of the involute gears. So involute gears are commonly used due to some greater advantages from the cycloidal gears. The following, the system of gears, four system of gears are used. The following four systems of gears are commonly used. First is 14.5 composite system. 14.5 degree composite system. 14.5 degree is the pressure angle. Second is 14.5 full depth involute system. Third is 20 degree full depth involute system. And fourth system is used 20 degree stub involute system. ओके इस पर बेस्ड एक न्यूमेरिकल हम लोग सॉल्व कर लेते हैं. Two involute gears of 20 degree pressure angle are in mesh. The number of teeth on pinion is 20 and the gear ratio is 2. The pitch expressed in module is 5 mm and the pitch line speed is 1.2 meter per second. Assuming addendum as standard and equal to 1 module, find first the angle turned through by pinion when one pair of teeth is in mesh. Okay, and the second, the maximum velocity of sliding. ये दो पॉइंट्स हमें फाइंड आउट करने हैं गिवन न्यूमेरिकल में. सबसे पहले जो डेटा गिवन है हम उसको नोट डाउन कर लेते हैं. Okay, two involute gears of 20 degree pressure angle. Phi has been given 20 degree. Okay, the number of teeth on pinion, let number of teeth on pinion is small t and the number of teeth of pinion is given 20 and the gear ratio is 2. So gear ratio, let gear ratio is G is equal to 2. We know that gear ratio is equal to the number of teeth on wheel divided by number of teeth on pinion. So from here, if gear ratio is 2 and the total number of teeth on pinion is 20, in that case total number of teeth on the wheel will be 40. Okay. Module is given 5 mm. Okay. Velocity, peripheral velocity, pitch line velocity will be given V1 is equal to the, has been given 1.2 meter per second. Okay, and addendum is one module. And module is given 5 mm, so addendum is 5 mm. Now, first angle turned through by the pinion turned through by pinion when one pair of teeth is in mesh. Okay, we know that module is equal to the diameter upon number of teeth. If the radius of the pinion is small r, in that case d is equal to 2r, or radius of the pinion will be equal to the module into number of teeth divided by 2. Module is given 5, number of teeth is 20, so the radius of the wheel will be, pinion will be 50 mm. Okay, and pitch circle radius of wheel, pitch circle radius of wheel. capital R is equal to M into capital T by 2. R is equal to 5 into 40 by 2. So the radius of the wheel will be 100 mm. Radius of addendum of circle of pinion RA will be equal to the small r plus addendum pitch circle radius of pinion is 50 and addendum is 5. So addendum circle radius will be 55 mm. Similarly, radius of addendum circle of wheel will be equal to the radius of the circle of wheel plus addendum pitch circle radius of the wheel is 100 and addendum is 5. So the radius of addendum circle of wheel will be 105 mm. Okay. We know that length of path of approach will be equal to the under root RA square minus R square cos square phi minus R sin phi. So length of path of approach will be it will be equal to the 12.65 mm. Okay, and the length of length of path of races will be equal to the under root RA square minus R square cos square phi minus R sin phi. RA is 55, R is 50, so the length of path of races will be equal to the 11.5 mm. So length of path of contact will be equal to the length of path of approach plus length of path of races. So length of path of contact will be 24.15 mm. Okay. Length of arc of contact will be equal to the length of path of contact divided by cos phi. Length of path of contact is 24.15 mm divided by cos 20. This is equal to the 25.7 mm. We know that angle turned by pinion will be equal to the length of arc of contact divided by circumference of pinion. Length of arc of contact is into 360 degree is 25.7 into 360 degree divided by 2 pi into 50, the circumference of the pinion. So angle will be 29.45 degree. Okay. Now come to the next part. Maximum velocity of sliding. Okay, let omega 1 is the angular speed of pinion and omega 2 is equal to the angular speed of wheel. We know that linear velocities will be equal. So omega 1 into r equal to omega 2 into r. From here omega 1 is equal to v by small r and omega 2 will be equal to the v upon capital R. So omega 1 will be equal to the speed is 120, radius is 5, so velocity will be 24 radian per second, and omega 2 will be equal to the 120 upon 10. So the velocity of wheel is 12 radian per second. So maximum velocity of sliding will be equal to the omega 1 plus omega 2 into path of approach. So Vs will be equal to the 24 plus 12 into 12.65. So maximum velocity of sliding will be 455.4 mm per second. Okay. Okay. Thank you very much.